and continuous. Discrete is like means the data is absolute, like when we use number, it means like 1, 2, 3, the absolute number. But continuous, it has range, like means include the, when you say 1 means can be 1.1, 1.11, or 1.1101, right? Any dots in this range can be included as the data for the continuous. For examples, discrete is like when we talk about car, means it's discrete, right? You can say 1.5 car or 1.3 cars, or human means you cannot say 1.5 human, but all men. So when we talk about kind of data means included in discrete. But continuous, for example, water, you can say 1.7 liters, or let's say for what other examples for continuous? Like we can say meat. You can buy meat for like the consumptions of meat, maybe 1.5 grams, or for food, some like one for diet, proteins, how many proteins you need to consume, and then fat, how many kilograms of fat, some kind of that informations will be group of continuous data. But for some conditions, even humans can be included in continuous, because like some probability, some distribution probability can be utilized for general conditions. One more example, like height or weight, it's also continuous, right? Okay. So when we talk about human, we can also utilize the continuous distribution probability. So, but when we use this parametric approach, it's easier, because like we already have many types, so the scientists already categorize many types of distribution probability, and it's already have the formulation, so you can just utilize those formulation to make any conclusions. So like I mentioned before, you can use normal distribution to conclude, or to predict, or to make a decision about, like, if I have some information from a sample. For example, if we say this X is represent height, mean this is the average height from a sample. then we can use this by use the formulation of normal distribution to conclude about the height of a population. Okay. But to group a data as normal distribution is have some rules. For example, the data needs to be more than 23 data and need to be random. So you must be ensure that the data is random. Means you cannot take only from a group of people like close friend or family, some people nearby. Means you need to this data represents all the universe or the populations you have, even though it's only 30. Means, for example, if the the populations is for example, for the new students is have 18,000 students, but you want to know the average of the height without taking measure all the height of the students, but you take sample from only 30 or 31 students. Means this 31 student must be taken randomly. So how you can make sure that this is random? Later on in descriptive statistic, you will learn how to take random data. Okay, that's only some conditions that need to be fulfilled when you use parametric approach. Some conditions will not allow us to have those parametric data, so we still can apply the statistic inference based on the non-parametric approach, non-parametric statistic inference approach. Means in this non-parametric, we don't have to fulfill the requirement of this distribution probability. Means the data is free distribution or non-distribution probability based data. But of course, this is have the consequences and need to be noted. So some scientists, or if you read in some papers or journals, this only allowed in some real. You need to convince the readers or the scientists that this approach have been done because the parametric ones is not possible. So actually it's also allowed because all these methods just as guidance for us to make a conclusions, right? So the real when you read a book in any kind of science book, some will mention that actually what we learn or we study, it's a guidance. but about the result, actually, is it true or not? What's because decisions we make will not have a 100% guarantee that it will have the best result actually, but with the good step or right step, actually we can make our, or we can take responsibility about the decision that we make, right? Not just a random decisions, or just based on the feelings, or based on the subjectivity, but we can how to say represent that our decision is objective, something like that. Okay, yeah, 1 more minute. Any questions?
I have a question.
Okay.
For this statistic inferential, does it the same as like the theory of probability? So do we study about distribution, something like that?
Actually, inference statistic will most of it utilize the normal distribution probability. That's why, yeah, I need to make adjustment actually for the way I deliver the material, because like before it easier, because the students who take the inference distribution already learned about the type of distribution probability. Yeah. But for this inference, maybe like I will like make introduction before about the normal distributions, because most of the methods will be based on normal distribution. So yeah, maybe next week, before we go deeply into the inference, we will like have the introduction about what is the normal distributions. Then we will learn about the central limit theorem. Because like why we can like based on this is a sample. When we say this is populations, okay, and then based on in the populations have the sample, right? Then we take some of the data here. So this is sample 1, sample 2, sample 3. So from this sample, we will like make conclusion about the population. Okay. What is the population? Later on, we will learn about the parameter. Something like that. Okay. Actually, this one we will learn first in descriptive, but okay, like next week, we will study about what is data, and then data to parameter, and then populations to sample. Okay. Yeah. Any other questions? Still confused, of course. Okay. But at least the simple example or the content of this course is from sample. You will conclude about the population. So for example, if you have the information about height from some sample, you will take conclusions about the height of the whole populations. Or if another examples, in production line, when you find some reject, will you say that the process is good or not? Just from one or two samples. So for example, this is height, this is reject, imagine one of line productions. You will not check all the product, right? Because it will take times. 100% check means you need to add one more process. Means when you can finish the production process only in 1 minute, but if you add one more process to do the checking, means it will take 2 minutes. Means your output will decrease, but you can reduce the process by 1 minute, remove the checking process, but to make sure the quality, you can just do random check. So every 10 product, maybe you can take one and then check. So you can still make sure the quality, but no need to do one more process. So you can conclude that the process still good when you find how many reject. Means from 1,000 product, means 100 time check. If you find 2 rejects, is it still good? Or if you find 10 reject, is still good. So the population is the production, the whole productions is the production process still good. So by only take some samples, you can conclude about the production process.
Is that what they call as hypothesis?
Yes. So this is the hypothesis.
Hypothesis.
So you for the height, your hypothesis is the height of this population is 170. So you just prove from the sample you take, and then you can say whether it's accepted or not accepted. The same for the case of the rejections. But maybe this is we will learn like almost near to the like one two maybe in fourth meetings. Like before we need to learn first why or what is the basic of these formulations to take these conclusions. Okay.